Today we're going to be looking at the range. Now the range is what we call a measure of variance. We've been looking at our data sets and we've defined the mean, the median and the mode. Now we can have a data set that can have the mean, the median or the mode can be the same, but the data set can be completely different. So these are not always the best measures of data. A more accurate way to compare different data sets is the measure of variance or variation. I've just spelled two words at the same time. Variation. And there's three common measures of variation. Other ways of describing variation are the spread or the dispersion. And the three most common ways of measuring variation are the range, the interquartile range, and the standard deviation. Now, range and interquartile range are things that we've already come across previously, but we're going to look at them in more detail. But the standard deviation is probably something that may be new to you, and we'll be looking at that in another lesson. So let's look at the range. The range is simply the numerical difference between the largest and smallest values of a data set. The thing that makes the range advantageous is it's very easy to calculate. However, the disadvantage is it ignores the central values. And it gives greater weight to the extreme values. It's more informative to state the minimum and maximum values rather than the difference between them sometimes. For example, in a test, if the lowest mark was 6 and the highest mark was 19, the range would be 13. For group data, we can find the minimum and maximum possible range by using the lowest and upper boundary values of that data set. So let's have a look at an example for that. So to the nearest centimetre, the tallest and shortest pupils in a class are 169 centimetres and 150 centimetres. Find the least and greatest possible range of heights. So the least, so let's look at 169. So 168 0.5 is the smallest number that can be rounded up to 169. And for the 150, the 150.5 is the largest number that can be rounded down to, well, if it's 150.5, typically if you're rounding up or down, you would round it up. But if, say, you had somebody who was 150.4999 centimetres, that would be rounded to 150.5. So that's why we have this as our least, the lowest number for our smallest range. So that would then give us 180 centimetres. For the greatest, we take the 169.5, so the same thinking as we did for the 150.5, 169.5 would be the highest number that we could possibly have, and we take away 149.5 can be rounded up to 150 as the smallest possible height of a student, and that will give us the 20 centimetres as the greatest range. I've done, I did a 0 here, not 180, just 18. So the intervals in which the heights lie are what we're looking at to find the greatest and the least ranges. Now, we mentioned the other degree of variance would be the interquartile range and also percentiles. So the lower quartile the median, which is the middle value, and the upper quartile divide the values into of a data set into 4 parts with an equal number of values in each part. So with the lower quartile we mark as being Q1, the median is Q2, and then the upper is Q3. The interquartile range is the numerical difference between the upper quartile and the lower quartile. I can't spell tonight. So Q3 minus Q1. That's the interquartile range. So let's, if we imagine our data set as this number line, here's our smallest value. Here's our upper value, our largest value. And then our interquartile range would be between, there's Q1, Q3, and then there's our median here. That's our interquartile range. Now, the interquartile range is often preferred to look at rather than just the plain range, because the interquartile range gives more weight to the middle values and not such a great weight to the extreme values, which we sometimes call these two values, the smallest and the largest value, as the outliners. So if we are looking at ungrouped data, so for ungrouped data, the positions of the lower and upper quartiles depend on whether there's an odd or even value. So we need to consider if odd or even number of values. So for even numbers, for an even number of values, we order the values and we split the data into a lower half and an upper half. Then Q1 and Q3 are the medians of the lower and upper halves. For an odd number, we split the lower and upper halves at the median, which we then discard, and then Q1 and Q3, it's meant to be a Q, are the medians of the lower and upper halves. So the median in an ungrouped data, the median is always, so the median is always the n plus 1 over 2 term value or value. But you can always find it by inspection. So let's look at a couple of examples. So, we want to find the interquartile range of 8 ordered values, which are 2, 5, 9, 13, 29, 33, 49, and 55. So let's get a number line. So the first one is 2, then we've got 3, we've got 3, it's a 5, then there's 9, 13, 29, 33, 49, and there's 55. So this is our first one, second, third, fourth, fifth, sixth, seventh, and eighth. So we can see here that there's 8 values, so the median point will be here. So there's 4 on this side, 4 on that side. This is Q2. So in here must be Q1, and in here must be Q3. So the value of Q1 is going to be, so we've got 5, it's in between 5 plus 9, so we look at these two values, 5 plus 9, and then divide it by 2, and we get 7, and the value of Q3 is going to be 33 plus 49 over 2, which is 41. So the interquartile range is going to be Q3 minus Q1, which is 41 minus 7, which is 34. Let's do another example. So I want to find the interquartile range of 7 values, and these are 49, 17, 43, 6, 73, 77, and 39. So again, we're going to do our number line and we're going to order them. So our lowest number was 6. Then we have 17. So we'll score these out as we go. 17, so we don't lose some. Then we'll have 39. Then we have 43. Then we have 69. Then we have 73. And then we have 77. So sometimes when you just got a list of numbers, sometimes the hardest thing is actually not forgetting one of them. So that's why it's good just to mark them off. So this is our first, second, third, fourth, fifth, sixth, seventh. So this time we've got an odd number. So our central one will be this one here. We've got 3 here, 3 here, and this is our central one. So here is Q2. So we ignore Q2, and then we look for the lower range of values. So we've got 3 here. So the middle value is 17. So that must be Q1. And the same with the upper set of values. We've got 3. So the middle one here is Q3. So the interquartile range must be Q3 minus Q1, which is 73 minus 17, which is 56. Now, you may remember from before we used the stem and leaf diagram, so we're going to use that in the next question. So find the interquartile range of 13 grouped values shown in the stem and leaf diagram. So let's do the stem and leaf diagram. dodgy 8. And then 5 and 8. So remember, with a 7-leaf diagram, we have a key. And this explains what we're looking at. So 14 in the line and a 2 represents 142. So 15, this would be 15, and 1 would be 151, it would be 153, 155, and so on and so forth. So we need to identify, so firstly we need to identify the median. So we have 13, so 13 plus 1 over 2 is going to be 7. So the 7th value, Q2 is going to be the 7th value. So let's go through them. So that's 1, 2, 3, 4, 5, 6, 7. So this is our 7th value. Now because there's an odd number, we discard this and then we look at the lower half. So it's between the lower half is between 142 and 151, and we have 1, 2, 3, 4, 5, 6 values. So for Q, so we're going to have 3 here, then the 3 here, so it's going to be between, it's going to be in here, it's going to be our value. So Q1 is going to be between 144 plus 148 divided by 2. And that gives us 146. Then for the next step is going to be for the upper values. The upper half, again we've got 6 values. And that's between 155 and 168. So 1, 2, 3, and 1, 2, 3. So in here is going to be our median. So Q3 is going to be between 157 plus 159 over 2, and that gives us 158. So the interquartile range is going to be 158 minus 146, and that gives us 12. Now we're going to look at group data. So for group data, we're going to use our cumulative frequency graphs. And we'll use that to estimate the position of the lower quartile, upper quartile, and any chosen percentile we might want. So for group data, the total frequency n is equal to the sum of all the frequencies. So the positions are going to be shown by this table. So we've got our quartile. So there's a lower Q1, median is Q2, and the upper is Q3. And the positions of these will be n over 4 or quarter of the sum of f n over 2, or half of the sum of the frequency of f. And for Q3 it's going to be 3n over 4, or 3/4 of the sum of f. The nth percentile is the value that's n% of the way through a data set. So we can say that Q1 is on the 25th percentile, the median is on the 50th percentile, and the upper quartile is the 75th percentile. Okay, let's look at an example. So we're going to have this graph here, and this is time in minutes. That's not time in minutes. This is time in minutes, sorry. Taken by 50 people, so it's 500 people up here to complete a task, and this is the graph. So we want to find firstly the greatest possible range. So what's the greatest possible range? So the top value here would come to here, and then we find the time here, which is 30 minutes, minus the shortest time somebody took to do the task, and you need to work out the what each square represents, and this is actually 2, so minus 2. So the range is 28 minutes is the greatest range. B, we want the interquartile range. So we need to find out what Q1 is. So for the lower quartile, it's going to be n over 4. The total frequency is 500. Over 4 gives us the 125th value. So we'll find 125, which is going to be down here. Come along to the line and then down, and that gives us Q1, and we find Q1 is going to be round about 8 minutes. Then for Q3 we do the same. We're going to do 3n over 4, which is going to give us 3 times 500 over 4 is the 375th value, which is up here. We read it along, and then read along here and then down, and that gives us Q3, which is going to be around about 6.5 minutes. Oh no, it's not, and that's it's 14.5 minutes. So the interquartile range is going to be Q3 minus Q1, which is 14.5 minus 8, which is 6.5 minutes. And finally, we want the 95th percentile. So what does that 95th percentile mean? It means the top 5% of people who perform this task will do it in this time. So we would do 0.95, turn the 95% into a decimal, times by the 500, that gives us 475th value position, which is up here. Come along, read down, and that gives us equal to, it's going to be the equal to around about 24.0 minutes. So I hope that helps. Okay, the final thing we're going to look at with regard to ranges and interquartile ranges is something called a box and whisker diagram. So a box and whisker diagram is a simple box, or it's also known as a box plot, is a graphical representation of data. And it just shows key features of that data, which is easy for you to look at. So these features are the smallest and largest values, it's the Q1, Q2 and Q3 values. And we put all these on the box and whisker diagram. Now it's best to draw them on graph paper to make them more accurate. So when I'm drawing these just now, they're not going to be accurate because I've not got graph paper. So what you would have, you'd have your graph paper, and then you would have your you'd have the range of data represented here. So this would be, say, 0, 15, and we've got some data set for X. Let's put 5, and then a wee bit closer. Just 5. And then, so this is kind of range of data. And then we would mark on it the smallest value. I'll draw it just now, and then I'll explain. This will be your largest value, smallest value. So this would all be on graph paper, so you'd have the little boxes marked out so you would know what each box represents. And then this would be Q1, Q2 and Q3. So this part here is known as the box. And this longer part here is the whisker. So the whisker is the range. And we don't draw the range going right through the box part. The box is the interquartile range. And if your data set has units, you would put appropriate units on them, just make sure it's labelled properly. Now in this example here, Q2 is actually, would be around about 6. The range is, so this is, the largest one would be 14, minus 1 equals 13, and the interquartile range would be 11 minus 4, which is 7. If you have a situation where Q3 minus Q2, if you've got two different, if Q3 minus Q2 is greater than Q2 minus Q1, and you were to graph that on your cumulative frequency diagram, the longer tail of the curve would be to the side of the smaller values. And if the opposite was true, you'd have the opposite orientation of your graph. And we say that this would be, in this situation, we say this would be a positively skewed data set. When, just do that, so when Q3 minus Q2 is less than Q2 minus Q1, we have a negatively skewed data set. If they are round about equal, we say that's symmetrical. So I hope that helps.